Ground, clearance, please. Ground, clear to start.
Brakes release, box of 33. Echoes, Seabird Concorde 1, protection.
Concorde 1, right turn on the southern taxiway 28 left.
Concorde 1, 2, left.
Happy, thank you.
What our order is, then.
So Concorde 1 now clear takeoff 28 left, the wind is north at 3 knots.
Concorde 1 rolling 28 left.
3, 2, 1, now.
Speed building. 100 knots, fast check. A1. Rotate. Austin 5, go. 240 knots.
This aircraft, the ME-163, could be flown and maneuvered at a Mach number of 0.82 in an era when there were few Allied fighters that could be maneuvered much above 0.72. So it was really untouchable as regards speed by any enemy fighters. However, it did provide a problem for the pilot. If it reached a Mach number of 0.84, was at its absolute controllable limit. If it was taken a fraction beyond that, it went into what can only be called a graveyard dive. There was no way out of it. It was such a tuck-under dive that it was inevitably a fatal crash.
Line 6. Line 7. 9. No, she hasn't been told. 9. I'm putting the stick forward.
The highest we've been to so far is 59,446 feet. At that height, the outside air temperature is something colder than that found at the North Pole, and the pressure of the air is a quarter that found on the ground.
As the Vampire taxied in, it had a noticeable list to port. The undercarriage oleo leg had been affected by the extreme cold at the record height of 59,446 feet. It looks what it is, a considerable step forward in airliner design, but not so radical as to require a prototype to be built and flown before production could be ventured upon. Indeed, a first batch of 16 was ordered and laid down straight from the drawing board. And in the evening, when the press had departed, and after a sixth practice run, Cunningham took the Comet off on a 31-minute flight before a crowd of workers who had just knocked off for the day, climbed to 10,000 feet, and then flew along the runway at 100 feet in salute. The Comet came in to a spontaneous ovation. Men who had worked a couple of years on the aircraft could at once sense that their product was a basically sound aeroplane.
In the matter of speed, we've been investigating the behavior of aircraft fitted with a gas turbine engine up to the speed of sound.
The aircraft broke through the sound barrier and then flew low over the airfield. Now the split-second disaster in slow motion. Far better not to show the harrowing scenes that followed. The heavy death roll is mute testimony of the dreadful tragedy.
We won't burden you with statistics about the size of this airplane, except to tell you that its wing spread is greater than the length of the Wright brothers' first flight at Kitty Hawk.
A shock wave is rather analogous to the bow wave of a boat. If for a moment you can imagine a series of fishermen along a bank of a canal, each would get his feet washed by the wave as the barge goes past.
Shock waves can even be seen with the naked eye in certain atmospheric conditions. Watch them streaming back from the nose of this missile. There.
We're now cruising at 28,000 feet. We're passing just to the north of Bristol, and in a few moments, as we cross the coastline and get out over the water, we will commence our further acceleration and climb. To do this, we'll once again apply maximum power, reintroduce the reheats, and you'll feel that happening. There's a slight nudge in the back of your seats, and accelerate quickly through Mach 1 until we attain a speed of Mach 1.7 when we no longer require the reheats and they will be turned off. At 50,000 feet, we'll retain the speed of Mach 2, twice the speed of sound, a ground speed in the order of 1,320 miles per hour.
We flew the Gerfaut for the first time on the 15th of January 1954 and were the first in Europe to reach Mach 1 in level flight on the 4th of August before going on holiday.
Pour les premiers en Europe, le 4 août, avant de prendre les vacances.
Oscar Tower from Murex 2, returning to base.
Roger, Murex 2. We all felt pretty miserable. We had reason to. That was our 6th attempt on the world speed record, and the ground crew were preparing for the 7th. Their refueling time is a record in itself. For the past 4 days, I've been streaking up and down the south coast near Brighton with the regularity of a local bus service. But on each trip, something had been wrong. Either I was slightly off course, I hadn't been within height limits, for one of the cameras had failed to catch up with me, and the tiny dot of an aircraft 7.5 miles up just wasn't on the photographic plate. And now we were all ready to press on with our 7th attempt.
Camera at Ford, all set. Register camera, okay. Weather's holding. Radar control, ready. Airfield clear.
Murex 2, change course onto 090.
Roger. Read lit up.
To Point Baker 5 miles. 5 miles now.
Camera side Charlie. Contact, contact.
Sight dog also, Murex 2. Port 5. Port 5.
Roger.
Murex 2.
5 miles to Point Charlie. 4 miles to Point Charlie. Steady on course. 2 miles to Point Charlie.
1 mile, Charlie.
Point Charlie. Point Charlie. Now.
Your vector's good.
Your vector is good. 6 miles to Point Dog. You are on track, Murex 2. 4 miles to Point Dog. Your position is good. 2 miles to Point Dog. 1 mile to Point Dog. Point Dog, Point Dog, now.
Oh, he's finished the run before we hear him start.
West-east run complete. Cancel reheat, throttling back. Fuel okay. Jet pipe temperature normal.
Recorder from sight, dog. A very good run, that. We made it just over 30 seconds.
Whilst outside world speed record conditions, rocket aircraft such as the Bell X-1 have for short periods flown even faster. And looking to the future and to still higher speeds, we see no real barriers which cannot be overcome.
What does 1,100 miles an hour feel like?
7.5 miles up, you get no impression of speed at all.
Will it feel fast near the ground?
Well, I'll put it this way. Imagine a trip from New Haven to Brighton, not at the normal 45 miles an hour, but at 5 times that speed. Then we'll fly you over the same course at 1,000 miles an hour.
Fairleigh Delta II had made another breakthrough. It was a delta. That meant that the wingtips were within the shockwave generated at the nose, and equally it was a slender delta, which meant that the air, which still has to be partied, was partied a little bit more gently than would have been the case with a straight-winged aircraft.
It was a strange aircraft. It had an odd shape, with a fuselage, well, with its cockpit placed above the enormous tank that is the Griffon, which, however, contained the rather mysterious engine known as the Statojet. which gave us the opportunity in the years 1958 and 1959 to fly very fast indeed. Mach 2, Mach 2.19 if I remember rightly, and altitudes of 6,000 meters, 18,000 feet, and which allowed us to train for supersonic flight in airliners.
I think the difference comes out in the need for the civil aeroplane to have a long life, to have very good fatigue characteristics, and of course for the people to be comfortable in flying in the aeroplane. They're not pilots after all, they're just you and my grandmother. So that you have to aim for a very normal existence in a civil aeroplane, whereas you can have rather a special existence in a military one.
At Mach 2, twice the speed of sound, the airflow flowing over Concorde has so much friction and compression in it that it actually causes the fuselage to warm up. In fact, the temperature rise is 160 degrees centigrade. Take away the outside air temperature, which is about minus 55, and you're left with the resultant temperature of about the boiling point of water, 100 degrees centigrade. That means that it expands by about 8 inches. There's a gap on the flight deck where you can get your hand during supersonic flight, but not during subsonic. But equally, the floor is made in such a way to compensate for that expansion. And that is one of the reasons why we say we prefer supersonic flight. There is simply so much more legroom.
the Boeing team stands ready to build America's supersonic transport. And when they do, the 2707 will shrink oceans and will bring closer the lands and the peoples of the 1970s and 80s and 90s.
I think one of the worst things that's happened to Concorde was that the Americans decided not to do a supersonic airplane. Because if they had done a supersonic airplane, even though there would have been pretty tough competition, there would have been a constituency on each side of the Atlantic who wanted it to happen. So transatlantic rivalry, or the transatlantic situation, was really pretty important. Environmental pressures were also important, but I would have been much happier with Boeing staying in the scene than the fact where Boeing dropped out of it.
Like Concorde aerodynamics, Concorde materials have had years of testing. In French and British laboratories, thousands of samples have been tried out. Many different kinds of material, aluminium alloys, titanium alloys, stainless steels, were examined. At the Royal Aircraft Establishment, Farnborough, an electron microscope is used to probe into the very elements of complex metals. Only after innumerable checks and tests was the final choice made for Concorde's main structural material, a metal used in aviation for the last 40 years, aluminium. This aluminium alloy, known as RR58 in Britain, AU2GN in France. Special laboratories like this one at Farnborough have devoted thousands of hours to establishing the creep resistance of RR58. Creep is the slow deformation of metal that can be caused by prolonged loading combined with prolonged heat. From these tests, this alloy has emerged triumphantly.
Kinetic heating imposes new demands on aircraft materials. Everything for Concorde is with heat added. So electrical furnaces are wrapped around test specimens to simulate the structural heating conditions experienced in supersonic flight. Stringent testing has demonstrated that in this new flight environment, RR58 has excellent fatigue life characteristics.
Like all Concorde activities, materials testing in Britain and France is dovetailed into a single coordinated program. Investigations in this Farnborough laboratory form one strand in a complex pattern of research.
This is the hydrodynamic tunnel operated by ONERA, the French National Aviation Research Authority. Colored inks injected into the water stream trace the airflow patterns over the Concorde wing at low speed. Rear view of the model in the same tunnel. As Concorde comes into land, these stable vortex formations will provide valuable and natural additional lift.
And here are the results on some of the many different glues that have been put to the test. There is a mock-up for every part of the aircraft. This is the engine variable air intake.
And this is the power plant mock-up, with a dummy engine being winched into position. During development, this job will be done hundreds of times to check that relocating any accessory has not affected engine installation or interfered with its servicing and maintenance.
In November 1962, a treaty was registered at The Hague between Britain and France to build a supersonic airliner that obviously was to become Concorde. In October 1964, Labour took over from the Conservative government, which had registered that treaty, and one of the first tasks that they faced was that of reducing public expenditure, especially on big aviation prestige projects. Their next task was to raise a loan of £900 million from the International Monetary Fund. A delegation went to Washington, and America insisted that should the loan be forthcoming, Britain would have to pull out of the agreement with France to build Concorde. So armed with this piece of information, Roy Jenkins, the Minister of Aviation at the time, was sent to France in order to state the British case. He arrived and gave a long speech stating what he had been told to say, whereupon the French delegation merely walked out. It transpired later, on cross-examination of some of their members, that if Britain were to withdraw from Concorde, the French would take us to the International Court, extract our share of the payments, and build Concorde by themselves. That crisis lasted until January 1965, and the next problem that hit Concorde was the cancellation later on that year of the TSR-2. Now, the TSR-2, Tactical Strike Reconnaissance Bomber, was powered by the Olympus engine, which was due to power Concorde.
I can't be sure when the decision was taken in Cabinet, but the decision was taken in the relevant Cabinet committee on the same occasion as we decided to cancel the P1154 and the transport aircraft. But Wilson was very frightened because there was much more public interest in the TSR-2 than the other aircraft to put it in the same package. So he asked us to delay it until the budget in April. And that's when the formal decision was taken and announced.
In order not to waste all the knowledge and the potential knowledge to be gained from these things, and also, of course, with an eye on trying to keep people in employment, not only in our factories, but in the component factories, the suppliers, we put forward a program to the ministry within 2 weeks of cancellation, proposing that the two prototypes should be kept on, I think, a 100-hour test and development program for research into the future Concorde test program, because they're very similar types of aeroplane. Much valuable information could be gained, and I think we put it forward on the basis of a fixed price contract. We were asking for £1.5 million to do 100 hours of concentrated research.
That the aircraft industry was consuming too large a proportion of our research and development resources, and also that it was too keen, for understandable reasons, not unworthy reasons, it was too keen on sort of breaching the frontiers of knowledge on aircraft design, rather than concentrating on making and selling planes which it could make and so.
That meant that the Concorde project had to bear the entire cost of developing that engine for Concorde.
For the first time, we saw the aircraft in its entirety, without scaffolding, painted, and we could appreciate its true size outside the hangar. And it was at that moment that its beauty, although it was to be further perfected in production aircraft, impressed us all.
The great day was interesting, to put it mildly, and very exciting, because we'd had 2 days of frustration with the failure flag on the first pilot's airspeed index popping up every time we did a taxi run up above 80 knots. And after about the third go to fix it, I said to the engineers and the designers, well, if it works this time, we'll go. We're not going to come back and tell you it's working. Unfortunately it was, and off we went.
Concorde 002 is clear takeoff, and good luck, gentlemen.
Fingers crossed. Il roule. Nous croisons les doigts. Full power and reheat. At this point, Brian Trubshaw decided to turn a high-speed taxi run into a first flight.
Hey! So obviously the ASI is all right.
For 002, a Fairford technique. Roger, understand working control.
02, you're clear to land from this approach.
Well, on an aeroplane where the pilot's eyes are very high off the ground when the main wheels touch, you need to be aware of the height quite accurately. And you use radio altimeters for the last, say, 100 feet or so, and they're called out either by the co-pilot or the flight engineer, in the case of the Concorde, and we were denied their accurate information on our first flight because they both failed during the flight from Filton to Fairford. It wasn't too bad. I think we arrived about a quarter of a second early.
After a 22-minute flight, Concorde 002 landed safely at the Royal Air Force Airfield at Fairford in Gloucestershire, the British base for Concorde flight operations. After years of careful study and dedicated attention to detail, here was another thrilling and rewarding climax for the thousands of men and women working in the factories of British Aircraft Corporation and Sud Aviation, in the knowledge that the British-built Concorde flew just 5 weeks after her sister 001, and that 2 Concordes are now flying. Brian Trubshaw said the flight was cool, calm and collected, and that the crew enjoyed it immensely. The usual press conference took place at Barnwell Hall, Filton. And here, a nice touch. Trubshaw and his crew were presented with a cream cake given by world-famous aviator Sheila Scott. As Concorde 002 is being towed to the hangar to be prepared for her next flight, let's quote Raymond Baxter's concluding comments on BBC TV. All they want now is to forget the ballyhoo and be allowed to get on with a real job of work, proving Concorde as an aeroplane, as a step to getting it into airline service.
Rigorous ground testing makes for trouble-free flying. On this rig, the Concorde undercarriage has been subjected to thousands of takeoff and landing cycles.
Now, as the Mach number increases, the center of lift moves rearward, in fact by about 6 feet. That would have the tendency of actually putting Concorde into a dive. Well, that's not a problem because you've got elevons at the back which you can put up in order to raise the nose again. But having elevons in the up position throughout the cruise would cause unnecessary drag or air resistance. The way round the problem is to pump fuel from the front trim tanks of the aircraft to one in the rear. And the central of gravity, in fact, moves by about 6 feet for the supersonic cruise. And the job of the flight engineer is to pump the fuel around the 13 tanks, which incidentally are numbered 1 to 11. We have a 5A and a 7A, in such a way that the elevons, the flying control surfaces to the rear of the wing here, are all precisely half a degree down, their most efficient aerodynamic position. And then, of course, at the latter end of the cruise, the fuel is pumped forward during the deceleration for use in the engines.
The takeoff is scheduled for without auto stabilization, so it'll be, and it's a fairly heavyweight takeoff, but as far as I remember, we're up around the Mach 75.
Taxi, correct left, 220, 6 knots.
1015, and we'll call it 08 off to reckons 15 minutes past the hour takeoff.
Right, no, that happens.
And their job was to monitor all sorts of temperatures and pressures, but in particular to get the air intake systems to work correctly. On that, it was absolutely crucial for the performance of the aircraft. A percent wrong either way would have ruled out the possibility of carrying any passengers across the Atlantic at all. And so the angle of side slip, the angle of attack, the speed of the airflow through the intake was crucial to the program.
We had to operate the aeroplane to get the maximum range, obviously, and in so doing, it meant that you operated the engine as near to what's called the surge line as you dared, and getting the margins correct, which meant tinkering with the intake, was quite a drawn-out performance, and it went on right through the whole development program.
So we went carefully, step by step, and were pleasantly surprised to find that aircraft handling was good up to Mach 2, and that even with 2 engines out on the same side, the pilot still had several seconds, which is a long time, you know, to regain control of the aircraft.
Mach 2 is now routine.
Then we were not only concerned to test fly at high speeds, but also at low speeds, to allow for landings under normal conditions. In other words, landing at higher angles of attack than would ever be used by normal aircraft. These were exciting tests. First, we tested straight landings, then simulating a sudden obstacle in the line of approach, another aircraft crossing our path, for example, simulating avoidance techniques. So we tested increasingly violent maneuvers at different approach speeds and increasingly brutal avoidance maneuvers. And then we decided to push the aircraft to its limits with the most violent maneuver possible, and I saw the angle dial increase. We had a small indicator of angle of attack, and the needle began spinning like a ventilator, and I realized that we would have to react quickly if we were not to put the aircraft at risk. The aircraft responded well. We had gone far beyond the conditions for which the design office had guaranteed the safety of the aircraft. All we had to do was to develop a better safety system, so that today it is impossible for the pilot to go beyond certain danger limits, even if his avoidance measures are violent at approach speeds.
Concorde's first intercontinental flight was to Dakar in West Africa. .001 flew back to Le Bourget 2,500 miles in under 2.5 hours. The present schedule is about 6.5 hours. Today's air transports and tomorrow's. even to the pretty stewardesses.
Well, in fact, both prototypes did a lot of promotional flying much earlier than you would normally expect in a program of this sort. And one of the main reason for that was that there were a lot of oppositions building up to Concorde, and it was necessary to keep the aeroplane in front of the world.
.002 has done its share of VIP flights. Australian government representatives go aboard to learn at first hand what Mach 2 is going to mean to intercontinental travel.
No sensible mother would feel happy about leaving her baby in the pram in the garden in the neighborhood of Heathrow while these Concordes are passing.
The SST is charged with doing everything but causing ingrown toenails, and I'll be surprised if the misinformers do not find a way to do that.
The Concorde demonstrates its responsiveness at low speed and altitude. Now taking off, the Russian Tu-144 supersonic transport by Tupelov.
We're now cruising at Mach 2, just passing 50,000 feet and still climbing. Our ground speed is approximately 1,320 miles per hour. And we will now maintain Mach 2 all the way across the Atlantic. If you'd like now to reset your watch to local time in New York, it is 5 hours earlier than London time. It's now 10 minutes to 7, and we will be arriving on time in 2.5 hours from now at 9:20.
It was in 1975 that the first Air France crews began piloting the aircraft during the qualification flights.
For pilots who had spent years at the controls of heavy aircraft, such as the 707, it wasn't easy to come to terms with an aircraft that handled like a fighter, which reacted to the slightest pressure of the fingers.
des petites impulsions légères en se pilotant presque entre des doigts.
They all felt the difference, but not all of them managed to come to terms with it. Not completely, anyway.
The training course for the Concorde conversion is probably the most complex course that there is in civil aviation. It goes on for about 6 months. From the time you actually start to the time you're finally finished and are flying passengers, it takes between 5 and 6 months for all our pilots. And it is a very intense course. The ground school course where you learn all about the switches, the dials, the systems, the limitations, takes about 2 months. And you fly in the simulator. It's a very good simulator. We fly 16, 17 4-hour details on that machine.
169 is selected. There's lead and director, they're on the glide slope, slightly, leader slightly to maintain. Okay, 500 feet, and the power and speed are now stabilized. Now we're coming down to 100 to decision. And our decision height.
Continuing.
And keep it there nicely, and remember as we come into the last 100 feet, lock onto that attitude 10 3/4 degrees. Gets 100 feet, 50 feet, 40, 30, 20, 15. Very good.
The simulator allows you to do all these things until you get them right.
Stick well forward.
That part of the course lasts for a minimum of 64 hours, which is quite a lot.
Reheats off at 500 feet, climbing until we reach 1,500 feet.
At the end of each week in the classroom, there's an examination. When the final exam has been passed, the simulator course completed, then you go to Prestwick for the base flying. That's when you actually handle the real aircraft for the first time.
Right, Stuart, we have clearance for takeoff. Now's the time. Only once in your life you take the Concorde off for the first time. And we're climbing 1,500 feet. See if you can contain it to that 1,500 feet, which is the circuit height. Right. Most people go to about 2 or 4. I suppose. Okay, we're all clear. Off we go. All set, everybody? Ready? Okay, 3, 2, 1, now.
My first takeoff on Concorde was a remarkable experience. Because there's so much power, although you're accustomed to handling the aircraft in the simulator, you don't actually get the feeling of being shoved up the back as it goes off down the runway like a scalded cat. In fact, it's a source of great amusement for the training captains to watch the newcomers trying to cope with the aircraft's performance and level off at 1,500 feet.
The main difference is, of course, the speed. And you have to learn the systems to cope with supersonic flight as well as subsonic flight. Also, at slow speeds, it's got a great deal of drag, and it's speed unstable in that respect. And that also takes some practice at learning the handling characteristics and learning how to cope with it. But once you're used to it and once you become familiar with it, then it's a joy and a delight to fly.
Unexpectedly in 1970, the Conservatives won the general election from Labour, but they only lasted to the best part to the end of 1973. So when the new Labour administration took over in 1974, Tony Benn, minister responsible for Concorde, had a policy of what he called open government and stated that Concorde should either stand or fall by its own merits.
There came a dreadful week when Wedgie Benn was about to cancel Concorde.
This is a business, and I've always declined to give a categorical assurance because I'm not going to decide whether Concorde succeeds or not. It's going to decide its own future.
British Aerospace sent out about 100 telegrams to some of us, and Dougie Barder and me and all sorts of people. And Dougie and I got together and we decided we'd ring our friends. So we'd ring our friends and say, are you interested in Concorde? They said no, we'd hang up on them. They said yes. We said, well, ring at least 6 of your friends and tell them to bombard Wedgie Benn, send them telegrams and letters and things like that, which they did. And thousands of people sent telegrams. Anyway, it didn't get cancelled that week. And this led to lovely times for me because I went up and it's testing days and things like that.
Well, it was Golden Night, the night when a whole lot of us who had tried to help save Concorde were aboard a week before she went into service. Brian Trubshaw, who was captain that night, came back and said, "Do you want to come up front again, Sheila?" And I came up front and he said, "Here you are, here's my seat, the left-hand seat." And I put both hands on the wheel, and of course she went straight up, reared up, took them off and she went down. She was so sensitive that I learnt that you can really fly her with a thumb, you know.
Well, it's an adjunct which is absolutely true, that if a project is to be cancelled, it has to be cancelled quickly. So Tony Benn's idea of open government, which meant lots of discussion, meant that the Concorde project was saved. And Concorde went into service with British Airways, the state airline, and Air France on the 21st of January 1976.
Well, we've had the most excellent supersonic lunch, and we couldn't be more comfortable, and it's the most tremendous and very exciting experience.
Well, the difficulty in Concorde's early operational days was the need to land in America. Originally, that was to be granted, but only to the federally owned Washington Dulles Airport. The real target was New York. That's where the big load factors lay. But the Port of New York Authority would not accept the federal ruling that we were allowed to land there. And so it was fought in the courts. So although Concorde went into service in January 1976 to Bahrain, May 1976 to Washington, it wasn't until November 1977 that eventually British Airways and Air France were allowed to fly their Concordes to New York. The question really was one of noise, and the whole secret of Concorde's success in New York to this day is the way in which the noise abatement procedures are flown. Now, the runways at New York are almost adjacent to the water immediately around the airport. And the noise abatement goes something like this. The start of takeoff run, the reheat is pre-selected, the throttles are advanced, 3, 2, 1, now. Stopwatches are started, and the reheat cuts in as the aircraft accelerates along the runway. 160 knots or so V1, 190 knots rotate, and then at 100 feet above the surface, Concorde commences the left-hand turn. In slightly less than a minute from the start of the takeoff run, the reheats are switched off, the engines are throttled, and so the residents of Howard Beach are avoided thanks to the left-hand turn, and when Concorde is adjacent to them, the engines are throttled back in any case. There's now a slightly more gentle climb, and then once clear of Howard Beach, the thrust can be restored, the bank angle reduced slightly in order to enhance the climb, and the aircraft continues towards the Rockaways, whereupon the throttles once more are reduced to a preset angle in order to creep over the noise-sensitive areas in this particular place as quietly as possible. Thereafter, once clear of the coast, thrust is restored to full, the climb continues, and Concorde goes on her way towards Nantucket. And it was the application of that particular procedure which in fact meant that the lot of the New Yorkers, especially around Howard Beach, became a far quieter one on account of the fact that the subsonic aircraft, which had also been troubling them, had to follow suit. During the development of Concorde, working at Filton was an Englishman, or maybe working in Toulouse was a Frenchman, with communist sympathies. So he sent the plans of Concorde to Tupolev, who was then supposed presumably to copy them. However, those plans were intercepted by one of the intelligence authorities and altered. Hence, Konkordsky, the Tu-144, was not such a success as it should have been. Now, had the intelligence authorities been truly intelligent, they might well have left the plans correct, in which case the Tu-144 would have succeeded, and with that succeeding, the Americans would hardly have dropped out of building their SST, and with their SST progressing, they wouldn't have tried to prevent Concorde coming to the United States in the first place.
Captain Robertson, ladies and gentlemen. In 200 miles, 10 minutes from now, we shall be commencing our deceleration prior to our descent for New York's Kennedy Airport. The time is now 20 minutes to 9 in the morning, and we will be landing at approximately 9:15 and have been disembarking on schedule at 9:20. The Kennedy weather is fine. There's overcast skies and the temperature is 30 degrees Fahrenheit, -1 degree Celsius, and we'll be landing towards the southeast.
Concorde is very, very important to British Airways. Along with Air France, of course, we're the only two companies to operate the aeroplane, and it sets us apart. It's something special. It's something very, very different. And no matter where you take the Concorde, thousands of people turn out to see it. It has that extra attraction and extra appeal. I think that clearly people make the implied thought that if we can operate and fly Concorde, then we must be a good airline. The other big benefit is that we fly as passengers on our regular flights, regular services. Many of the world's decision makers, the politicians, the businessmen, they fly in Concorde because they need to save the time, they need to use that which Concorde offers, which is to get you across the Atlantic very, very quickly. So it does mean that if we impress those people, that we stand a fair chance of getting some extra business from their companies. But my belief is it will be quite a long time before we actually see a successor to Concorde. And so for the next 5, 10, 15, probably even 20 years, I think the future of supersonic flying still remains Concorde. It's way ahead of any opposition, and it's in service and flying every day.
Okay, well, Concorde as we stand today could only be just halfway through its life in years. It has terrific advantages, of course, insofar as we operate it in these relatively warm conditions, 100 degrees centigrade for the fuselage during the cruise. So it's bone dry. We don't suffer like the subsonics do from, for instance, the problem of corrosion. It's remarkably well serviced, and the rate of using of possibly one crossing per day. Aeronautically speaking, Concorde is still a relatively young aeroplane. But what of the future? Well, the Concorde successor will have to have various attributes built obviously on Concorde experience. It would have to have far greater range. We're talking about Europe to the west coast of the United States. It would have, for instance, to be efficient both in a supersonic and a subsonic cruise. That subsonic portion would be at Mach 0.95, which of course is still faster than the jumbo jets, which cruise at roughly Mach 0.85. But gazing even further into the future, would it be possible one day, for instance, to do a suborbital hop from Heathrow to Australia, taking about 67 minutes? Well, being an optimist about such things, I'm sure that will happen, but not just yet. Such an aircraft would have to be derived from a single-stage orbit vehicle into low Earth orbit. The sort of engines needed for that would be a hybrid engine, or hybrid engines. I think the latest proposal on Skylon, the uprated HOTOL, is to have 2 such engines. They would be air-breathing for the first part of the launch. And then when the craft was traveling too quickly, in excess of 5 times the speed of sound, let's say about Mach 5, it would then convert into breathing liquid oxygen, which would be taken on board the aircraft, the vehicle, I should say, at the start of the mission.
One could see, for example, a version which would be simply passenger carrying, to carry people into space, to space stations, and back to Earth on regular servicing missions and so on. One can see pure tanker versions of HOTL for the purpose of carrying propellants into space efficiently. And then, of course, developments of the cargo version. But also, somewhere in the distant future, when the hydrogen technology is pretty well mastered, then the possibility of civil transport by ballistic airliners based around HOTL-type concepts may well be feasible.
Well, I think all of us that have flown Concorde become attached to it. It's a magnificent aeroplane, the most tested aeroplane that there's ever been, and it handles superbly. Once you've been through the course, once you become used to it, you never become overconfident with it, but it's like driving a racing car, it's like riding a stallion. It really is something special. It's very exciting, and I think, well, I've been flying it now for almost 20 years, and it's still a thrill each time I take off, each time I come into land. And it's still something really special when you're sitting up there at 60,000 feet and watching the world go past at Mach 2. It's apart from the rest of the aeroplanes.
I think the Concorde is a wonderful example of what you can achieve, sometimes in spite of politicians, if you really mean to. I mean, nobody thought that such a complex project could be made to work the way Concorde has worked. And it did work because nobody was going to allow it to be a failure. I think everybody that was involved on both sides of the channel were tremendously proud to be in it, and consequently they got on with the job. Every now and again somebody interfered at the top, but it happens, and it shows you what you can do, but you have to have determination.
So I would just like to conclude by saying that at the base of the whole project there is an essential ingredient found in all of the people who worked on construction, those of us who test flew the plane, and those who've been operating it, and that is passionate enthusiasm.
The Concorde has had a big bearing, in my view, on the very successful formation of Airbus industry. And Airbus industry has become, and will always be, a great competitor to the American aircraft industry, which up to the arrival of Airbus industry was dominating really all of the civil world.
Well, if someone were to ask me what I think of Concorde, I've got to say it ranks with the great architectural marvels of the world, the Gothic cathedrals, the Renaissance architecture of Rome. In short, everything has been honed to perfection. It's one of the few aircraft in which you can travel and actually grow younger. You arrive in New York an hour before you've left, watching, if you leave in the evening from London, the sun rise again in the west. And in the opposite direction, you don't need to be an Einsteinian physicist to appreciate that travelling at twice the speed of sound with the spin of the Earth towards the east, you lose weight, thereby justifying the superb cuisine. Concorde, in short, is the ultimate form of transport.
Concorde 1, contact the New York Center 13215, good morning.
Close 10 miles.
Seabird 1, descent across 40 miles southeast of state and maintain 12,000, Kennedy, altimeter 29904.
Altitude 1 to go. Check, that's 1 to go.
Concorde 1 heavy, New York, approach 1, 300,000.
Conversion advisors going.